I'm based in Switzerland. I am an independent software engineer, but I work predominantly. I have my consultancy called GeoVisually, but I work predominantly with the Unfolded team at Foursquare, where we develop Unfolded Studio. And I'm the creator of FlowmapBlue, which I will be speaking about, and FlowmapGL, which is a deck.gl layer for representing movement of people. And it's a little bit special, like the way it uses deck.gl. That's why, yeah, I will be telling you about this. And this is my second time in Spain. The first time I did the trip through the whole country, but I was asleep through the whole trip, unfortunately, so I didn't see anything. So I actually traveled from Switzerland, where I'm based, to Portugal, to a conference, and it was in 2010. And because of this guy, the eruption in Iceland of this volcano, my plane was canceled, and I took a 30-hour train trip with 7 changes to Guimarães in Portugal. And it was an important conference. It was like my first conference where I presented my thesis work on flow maps 12 years ago already. And I developed this, like as part of this work, I developed this tool called JFlowmap, an open source it, and it was a Java application for visualizing flows on a map. Yeah, it wasn't very pretty, it wasn't very user-friendly, but still quite many people tried to use it. And that's why I understood that there was a demand for such a tool. There were not many tools allowing to do that. Yeah, after the thesis, I worked at a design studio at several companies, and I still had this urge to work on something in this direction. And when I had an opportunity, we developed some projects visualizing flows. But still, I felt that the problem is not solved. Yeah, then I joined this company, Teralytics, in Zurich, where the company works together with telco providers and develop pipelines for aggregating data from telcos, looking at how people move in cities, how many people move from between locations, and how it changes over time, like for transportation authorities or urban city planners. And that's where I developed this tool, the dashboard, showing movement of people in cities. And this was before deck.gl. So this is SVG and a custom Sleepy map implementation in React. It kind of worked, but it wasn't very performant. As Xiaoji also mentioned today, SVG doesn't work well for larger numbers of objects. And as soon as deck.gl came out, we started experimenting with it, and the second version of our dashboard was already using deck.gl, and we developed this custom deck.gl overlay, FlowmapGL, which I also could persuade my managers to open source as a library. So FlowmapGL is a deck.gl layer which anyone can use. Yeah, after releasing it, I realized that the overlap between the people who are interested in mobility data and people who can code in JavaScript is not that big. So I developed a tool called FlowmapBlue, which people can use without any, you don't need to code to visualize movement data as a flow map. You just need to upload, create a Google spreadsheet in a specific format, and then pass the URL to the application of the spreadsheet, and then you get a flow map visualization without any coding. And quite many people have been using it. The tool also won the Information is Beautiful Award in 2019. And so it has been quite successful. Yeah, there are some tweets about different people using the tool. So what is a flow map? It's a representation of entities moving between pairs of geographic locations, like there are origins and destinations. The routes are not that important. It's important how many people are moving. So the amount flowing or the number of people moving is represented, can be represented in different ways. Often it's thickness, like in this case, but it can be color or number of particles if it's a particle animation. There are different approaches to that. The direction is also important usually, and it can be represented in different ways using arrows, color gradient, or animation, curvature, or the form of the arrow. And this is like a typical structure of the data table with origin destination data. We have a column for origin destination and count the number of people moving. Obviously, in this case, you also need the separate table with the locations of the origins, the coordinates of the locations. So for the visual design, there are quite a few decisions I made in this layer. So I use the thickness to represent the magnitude of the flows and also the color. So there's the redundant mapping so that larger flows are more salient. I also use sorting so that the largest flows are at always above. I use arrow outlines, like dark outlines that are hardly visible, but they prevent like the arrows. If there's usually often a lot of overlap in such visualizations, and without the outlines, arrows form just a single blob of color, which is not very readable. And I use fading, so the smaller flows fade out. Like I'm not using opacity, but really fade the color to dark or light to black or white, depending on the base map color, so that it can blend with the map. And you can adjust the fading intensity in the tool. So I also use blending with the base map using just CSS blending. There's this CSS property mix blend mode. And you can, like, depending if your base map is dark, you should use screen. If it's light, you should use darken. But as a result, you can basically, even if you have lots of arrows, overlapping arrows above the map, you can still read the base map. And it's quite important. So also I represent location totals. So this is, which is optional. You can switch it on and off in the tool. So location totals, it's like the total number of flows incoming or outgoing. And there is an alternative way of representing the directions using the animated arrows. So these are not arrows, but animated flow lines. It also shows the flow direction, but it often generates an emotional response, right? People can react to it more, but you should be careful with it. If you present like refugees moving to a certain country, this might not be the right emotional response. Yes, and I've seen people using it in unexpected ways, like to represent vector fields. These animated flows, there was a researcher who built a bird migration model, like birds moving, migrating in Europe, and represented it as a vector field. So yeah, often like there's often a problem with flow map representations that you have too many arrows, and they many of them are actually noise. They don't add much to the visualization, and also if you have to draw a lot of them, the performance suffers. So what I do in FlowmapBlue and FlowmapGL, I do adaptive filtering. So depending on the viewport, we show more or fewer flows, like only the flows which either end or start within the viewport. And this way, yeah, like basically only display top 5K flows at any moment and adjust the scales, like so that when you zoom in, you see more detailed representation. So it helps improve the performance. We remove the clutter, the noise, and we can explore smaller regions in more detail. But some data sets still look messy. So like in this case, we have bus travels in Sao Paulo, lots of overlap and many arrows of similar magnitudes. Or in this case, we have migration in Australia, where like we have densely populated regions across the coast, and the largest flows are also very short. So we don't even see them at this scale here because they are so short. So yeah, when I realized that, I saw those data sets, I thought of ways to create a useful summary. So I looked into clustering and used a similar hierarchical agglomerative clustering approach. Simple. Based on the library Supercluster by Vladimir Agafonkin from Mapbox. So basically, we find the largest locations with the largest. It's a weighted approach, yeah, with the largest numbers of flows, and start from them, and then we group locations which are close to them together with them, form clusters, and then aggregate the flow lines between those aggregated cluster, between the clusters. So this way we get fewer locations, fewer flows to render, and a better overview. So for the two examples I've shown before, this would look like this, much more readable, although we kind of lose the detail. But since we can do the clustering on the fly, and it's pretty fast, and apply like adaptive clustering and filtering to the viewport, adapted to the viewport on the fly, we can like use interactivity to still see the detail and explore the smaller regions. So here we see airplane connections between all the airports in the world, and you can see that when we zoom into smaller regions, we see much more detail. And when we zoom out, we see a readable overview. So a little bit about the implementation. So in Flowmap.gl, in the latest version, and I introduced Flowmap data providers, which is like another alternative to pass in a data array, which to the layer, which is the normal approach in deck.gl. With this data provider, first it can be async, so I can send requests to a database, or I can do the calculations in a worker thread. Yeah, and we can like plug different implementations. Yeah, and it has a set Flowmap state, so which has some settings for the Flowmap visualization itself and the viewport, and also potentially some filters in this data provider. And we have get layers data, and get layers data is an async method which returns layers data in the form of attributes with typed array buffers, which can be sent directly to the GPU. So there is in the deck.gl documentation, there is a great article about performance, which describes this approach. Thank you, Shaoqi, for that. Yes, and Flowmap layer itself, like unlike the normal layers, deck.gl layers, it updates itself. So it adapts to the viewport when we zoom or pan in the map. And of course, if we change some settings. So yeah, in the update state method of the layer, we have this set state layers data, and layers data comes from the data provider. And this is called every time the viewport changes, so that the layer adapts. It can often it makes sense to introduce some throttling so that it really doesn't update on every frame change. So currently I'm working on the commercial version of FlowmapBlue. I'm trying to put it out in the next months. This is my side project, and it uses an arrow-based data provider. There will be a talk about arrow and GeoArrow today. I'm really looking forward to. Kyle is giving it, my colleague at Unfolded. But Arrow is basically a very efficient in-memory format for storing columnar data. And on Arrow, we can efficiently execute queries on data. And in Flowmap City, I do this in a worker thread. And here's a small screen recording of a relatively large data set. It's like mobility, passenger mobility model across the whole Switzerland. And yeah, we can look at it at very different scales. And like every time I change the viewport, there is a query. There are multiple queries actually to the data provider to update the viewport. Yeah, and you can maybe notice that yeah, when you move the viewport, the data comes with a little bit of delay because there's a calculation on the worker thread, and once the data is back, we update the view. But we are not blocking the main thread because the calculations are done in the worker. Yeah, this is pretty much it. What I want to share with you. And yeah, I also want to thank Xiaoji again and all the people contributing to deck.gl for such a great library and building the ecosystem around it so that many people, many different projects, many companies can benefit from it.